So, question number 3. When using the when taking samples of n equals 5, what was the shape of the distribution of means histogram when the parent population is right skewed?
Where are we at?
Question 3 in the group meeting.
Give me a second.
Yeah, you're fine. I just kind of jumped in. Is it talking about the actual graph thing we have to do? Let me pull it up again.
Yeah, I don't know.
Yeah, it's a weird question. But maybe it's talking about that, the link
Yeah.
that they had us go to. It's already to n equals 5.
And on the mean.
What?
I said and on mean.
Wait, are you guys taking the quiz already?
Yeah. Yeah, that's
Oh,
what we're doing.
got it.
Yeah. Yeah. We're just on question 3. Because the first 2 are just,
Yeah.
did you do?
Should be skewed right, shouldn't it?
Are you looking at the graph, or what? Are you looking at the graph that the link sent you to in the reading?
Yeah.
Okay, yeah. Okay.
Maybe not.
So right skewed, or skewed right. All right, so when taking samples of n equals 100, what the shape of the distribution means histogram when the parent population is right skewed. So just change. Okay, mine just froze. How are you? Are you guys on number 4?
Yeah.
I'm trying to get n to equal 100, but it's not working for me. Let me see.
Yeah, it only goes up to 25, right?
Yeah, that's why
Yeah,
I'm
that's
confused. I'm going back in the instructions to see if it says somewhere if we can make it higher. Yeah, it says it only goes up to 25.
So could we just like
Get?
that?
I don't know.
Well, I think if we I mean, if we just do 25 and we do it, how many times does it want us to do?
100.
Because I think the higher it goes, the more normal it's going to be, right?
I think so.
Yeah, that makes sense.
So I would assume that if it's 100, then it'd
Be
look more normal.
Okay.
That's
That
just
makes sense. That makes sense. Okay, so number 5, when using the sampling distribution applet when n equals 5, what was the shape of the distribution of means histogram when the parent population is normally distributed?
sample.
isn't the sampling? Isn't that the thing we used from the last lesson?
I thought this was it right here. The sampling, the one that we were just using.
Yeah, I
Oh.
think that's the
I thought
sample.
it was the histogram thing. I don't know. Okay. All right. So when
It's
n is
normal.
equal to 5, which is already wait, I gotta change mine. Normally just.
I think it's still going to be normally.
Yeah. Yeah. All right. And same thing for n is equal to 100 when it's normally distributed again. Now this one I don't know. I feel weird not being able to do it on the thing.
Yeah, that's kind of weird.
Trying to figure out how to get it to go, but
So in the instructions it says it can't go up to 100, right?
yeah, I was just trying to find where it says sample size can be set to 2, 5, 10, 16, 20, or 25 from the pop-up menu. I'm looking at it again.
That's fine.
What happened? Sorry, my computer just freaked out. Well, if we're going off the same logic that we did last time, wouldn't it still be normal?
Yeah, I
With
think so.
bigger?
Yeah.
I know. I don't feel like we're going to go wrong, but it's okay. All right. So, when would the distribution of means be normally distributed? Let's set that on the. Where is it? Let me find it real fast.
So whenever the sample size is big, that's when it's going to be most likely normal.
Yeah, I think so.
So the two
The
normally
second one.
distributed, and yeah, the second one and the fourth one.
Yeah.
They're both. Oh yeah, okay. Because it's normal and right skewed. Okay. That's why it's different. Okay. Which of the following gives the best explanation of the central limit theorem? So central limit theorem. It's number 2 on the sheet we had to read.
Is it 4? Number 4?
Yeah. I'm just checking the definition real fast.
You're good.
Number 4, you said? Yeah. Okay, yeah. Let x be a random variable with a population mean u equals 10 and population standard deviation, that symbol, equals 6. Suppose a sample of size n equals 36 is drawn from this population. What does the mean of the distribution of the sample mean? How are we going to be able to do that if we can't change it on the graph?
There should be a formula that you use with the mean u, the standard deviation, and the sample size. I can't remember.
Here, I'm on it right now. Let me see if I can find something.
So the mean of the sample mean is standard deviation is the, I don't know what symbol is.
Oh, okay.
Over the square root of n.
Oh,
yeah, they had that. It was, where was it?
It's under number 3 in the reading.
Okay, yeah, 3 and 4.
but
Okay.
So the little squiggly, like the thing over n, that's the standard deviation. So standard deviation over square root of n, right? Is that what you're talking about?
Yeah.
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 Um,
Okay,
I,
so the
how do we
standard
find n though?
deviation.
Oh,
Don't we have the standard deviation?
yeah.
So
So the
yeah,
So
square
we
root of that.
divided by the square root of 36.
Yeah, so I'm just
so
The mean is
1.
1.
Yeah.
Yeah.
But number 9 would just be 10, right?
10.
Yeah. Or
It would just be what?
just be 10 because it said the
Oh,
distribution of
yeah.
the sample mean.
Oh,
Yeah, we were
yeah.
doing 10 off.
Okay, yeah.
Yeah.
And then the standard deviation,
Of the sample means is
that
what we were just doing.
that would just be 1, yeah.
Yeah.
Okay. Was it enough? Okay. Regardless of the distribution of the population, if the sample size is large, what would be the shape distribution of the distribution of the sample mean?
Would be
Would it
normal.
just be normal,
Mhm.
right?
Yeah.
Okay.
What theorem?
What theorem would justify your response to question 11? Wouldn't it be the central limit theorem? Or wait, is that what it's called? Yeah. I don't think law of large. Oh, yes, there it is. It's a thing.
Yeah, large law of large numbers is pretty much the same thing, but it's um, I think that has to deal with more of like percent, I think, or something like that. I was
Yeah.
just
Yeah, it has to deal with like the mean.
yeah,
The mean correlating with the standard deviation, coming closer and closer to that. That's what it looks like
that's
in
it.
the I'm reading.
Yeah.
Okay, so it would be the central limit theorem.
Yeah. I'll just make
Awesome. Awesome.
Alright.
Sweet.
Should we submit?
I submitted it.
Perfect.